So next topic is stepper motor. Stepper motor. So what is meant by a stepper motor? You have studied what is motor. What is motor? You give electric voltage, the motor rotates continuously. That is what normal DC motor is. If you give DC voltage continuously, the motor rotates continuously. That is called DC motor. Stepper motor is input as well as output. There are differences. In stepper motor, we give pulses as input continuously high and low like this. You have to give electric pulse as input. The motor, whenever you give one pulse sequence, the motor rotates certain angle and stop for some time, then after that again certain at that same angle, like this, like this, like this, in steps it rotates. So stepper motor takes electric pulse as input voltage, and in response to electric pulse as input voltage, it rotates not continuously, it is rotating in steps. For example, if it is step angle is 2 degree, means first pulse sequence it will rotate 2 degree, then stop for some time, then again next electric pulse sequence 2 degree, like this it goes. So stepper motor is something which takes electric pulse as input and rotates in steps. That is called stepper motor. For example, printer and all, no, slowly it has to rotate in steps. So we are using stepper motor. Now we can control this electric pulse by giving through microcontroller. The sequence can be controlled. So stepper motor can be controlled by 8051 microcontroller. So let us see how the circuit diagram is. So you know that any motor including stepper motor will contain a rotating part which is called rotor, and stator windings where you give the electric pulse. So it is split like this. So four terminals are kept outside: A, B, C, D. Now this A, B, C, D has to get pulses from 8051 microcontroller. So I can use 4 port bits. Let us say P1.0, P1.1, P1.2, P1.3. Now, the current given by this microcontroller will not be able to, it is very low, so that it will not be able to drive this stepper motor. So, in between, you have to connect an IC called ULN2003, which is a current driver IC, which amplifies the current from this microcontroller to such a level so that the stepper motor can be driven. So, through this driver IC, you have to connect to stepper motor 4 terminals. A, B, next port bit to C, next port bit to D. Now, through pull-up resistors, you have to connect this 5 volt to all these lines. So, usually 47K resistor can be used, all 4 lines. So, all 4 lines through 47K resistance, we are connecting this to plus 5 volt supply. Now, this mid terminal of both windings are connected to plus 5 volt. Okay, this is how you have to connect the stepper motor through ULN2003 to microcontroller 8051. Now, how to control this sequence? So, when you control the electric pulse sequence, so you will be able to control the stepper motor. How you have to control? There are two methods. One is called normal 4-step sequence, because we have 4 terminals A, B, C, D. Normal 4-step sequence, in which what you have to do is you have A, B, C, D. For this winding A, and for this winding D, will give 1 first. Other 2 lines will give 0. Okay. Now you have to rotate this sequence. That means rotate this sequence. So 1, 1, 0, 0. Then right rotate. So 0, 1, 1, 0. Next 0, 0, 1, 1. If you do like this, if you right rotate, right, if you do like that, the motor will move clockwise direction. And if you do reverse, you start from somewhere here and do left shift, it will rotate anti-clockwise direction. So clockwise direction, this way you have to move the right shift you have to do. Take any of these values, better will take from here because both I can do, right shift and right shift, left shift. So you know that it is 0, 1, 1, 0. So it is connected to where? P2 point. You can see that it is connected to, sorry, P1 point 0A. So this is P1.3, P1.2, P1.1. This is P1.2. So P1.1, P1.0. So if you take P1, so it is P1.3210. This order you have to take 0, 1, 1, 0. That means 6. And the remaining port bits P1.7 to P1.4 are not used, so give the same value. So 66 you can give. If you give first 66 and then do right rotation, you will get clockwise direction movement, step movement. If you do anti-clockwise, if you want anti-clockwise, you have to do left shift. That's all. Start from 66, any of this value, and if you move right direction, it will move clockwise in steps. If you do left rotation, it will do anti-clockwise. So let us write the program. So first take one value. I will take any value I can take out of that. So I will take that P1.3210 should come 6. So I will, this is not important. So I will make 6 only because we are doing right or left rotation. So 60H. Now we have connected this stepper motor to P1 port. So I will send that value to P1. So one value is given. Then one rotation happened. So do clockwise direction means do right rotation RRA. Then after each rotation there should be some stop. So call some delay subroutine. You can use software subroutine. Software subroutine means loading some value in 1 or 2 registers and remain in the loop with the DJ and Z instruction. Then this process has to continue. Sending rotated value to P1 continuously. So this is the program to rotate. Now we have tried the delay subroutine. So delay subroutine can be very simple. Use software delay. Don't use timer 0, timer 1 and dot. Load some value in R2 register. Small value is enough. Let us say I am using 10H. Any value you can load. Then another register. One register will be small delay. This you can load full. FF. So DJ and Z, R1, loop 1, remain there itself. When that is over, DJ and Z, go to the next DJ and Z, R2, loop 2, loop 2 here. And last line of subroutine is return RAT. Okay. If you do like this, it will move clockwise. Now, if I do RLA here, left rotate, it will do anti-clockwise. This is what you are supposed to do. Now, let us take one question. Both condition. Let us take one example. Assume that you are having a switch connected to P2.7. Switch is connected to P2.7. If it is 0, clockwise. If it is 1, anti-clockwise. So both conditions are there. So what you can do, there is an input port bit which is connected to switch. So set bit that It is connected to P2.7. So P2.7 is configured as input port bit. Now give some value. For normal sequence, you can give the value 66H. Okay. Now don't shift right or left here, because either it has to do clockwise, then right shift, anti-clockwise left shift. So that you have to check. Based on what? Based on P2.7. So jump on no bit P2.7. You can do what? No bit means 0. 0 means clockwise. 0 means clockwise. Now other condition. So we will go and do clockwise rotation later. So that we will do later. Clockwise we will do later. Okay. Now here is bit. That means 1. 1 you have to do anti-clockwise. So anti-clockwise means what? Left shift. After left shift, send it to P1 port, because we are connected stepper motor to P1 port. Then some delay. A call. Some delay. Space is not enough. Now one rotation has happened. After one rotation happened, again you have to see whether that bit has changed. So go and check again. S jump back. Back is to check whether it has become switch position has changed. That means here. Okay. Now clockwise you have to do right shift and send it to P1. Call delay. Same delay. After calling, once again you check whether the bit has changed, whether continuation of clockwise or anti-clockwise is required. Now you can write the delay program subroutine by software delay, as we have done in the previous question. So delay subroutine move R2 comma hash 10H R1 comma hash FFH DJNZ R1 comma loop 1 DJNZ R2 comma loop 2 return. This is one chance. Now sometimes they may ask, you don't have to continuously rotate. After some rotations you have to stop. For example, they may say write stepper motor program to rotate stepper motor up to 70-degree. If one step angle means one step angle is 2-degree. That means in that case you are supposed to do what? 70-degree you have to rotate. One step is 2-degree, so you have to do 35 times. So you should not write S jump back. You should keep this 35 as count in some register, and wherever you are having S jump back, you should write DJ and Z. For example, R3 if you have kept DJ and Z R3 comma loop. See, this is what you are supposed to do. So I hope you understood. Let us say clockwise, if you have to do 70-degree for one step, 2-degree means 35 times you are supposed to do. So 35 should be kept as count. 35 should be kept as count, and that many number of times you are supposed to do. So let us take an example. Let us take this program. So you know that 35 convert to hex. Convert to hex 35 in calculator. So you know that 35 hex number is corresponding is 23H. So this 23H is kept as counter in some register R3. R1, R2 I will use for delay. No, that's fine. So R3 I will keep 23H to say that we want 35 times. Now what I will do? Move. I will keep 66H. I'll keep 66H. 66H can be kept here. Rotate and send it to P1. So one sequence has been sent called delay. So one sequence has been sent. So DJ and Z R3 back. Rotate once again. So like that, when R3 35 times over, it comes out of the loop. It comes out of the loop. Now you can write a delay program, subroutine, delay subroutine. You can write like normal last question only. So this is we are supposed to do for 70° for 2° step angle. Now there is another way you can control the stepper motor, which is called four-step wave drive sequence, normal sequence, wave drive four-step sequence. In that case, what you are supposed to do is at a time you are making only one bit as 1. So first give 1 0 0 0. Next you have to give 0 1 0 0. Next 0 0 1 0 0 0 0 1. If you move like this, right side clockwise direction, left shift, it will be anti-clockwise direction. So the value to be loaded is, in that case, you can start from any value. Let us say this only will start with. So 1 0 0 is 8. So other also will take 8. So 8 8 you start, or this will be 4 4. 0 0 1 0 is 2. So other is not connected, make same 2, or 1 1. Anywhere you can start and do right shift, you will do, it will rotate right clockwise direction. If you do left shift, anti-clockwise direction. That is called wave drive sequence.